Alright, welcome back everybody for the second part of the alternating series test lesson. And in this part we're going to talk about alternating series error estimation. And so what happens here, if we think about what happens when an alternating series converges, the whole idea that u sub n is always larger in magnitude than u sub n plus 1 once we get to a certain point, that gives us a very easy way to determine the error when we truncate an alternating series. If we want to estimate it with a finite number of terms, we can very precisely estimate the maximum error that could possibly occur. And if you think about it, what happens is we start at 0 and we add the first term of the alternating series, which might take us over to here. Okay, so this is just u sub n, or u sub 1, pardon me. And then when we add the next term in, it has opposite sign, so it's actually going to decrease the value of what we have, but it's going to be somewhat smaller than maybe I should use a in here instead of, because these are actually the alternating. So it takes a little bit off, but not as much off to take us past 0. And then the next term is a little bit smaller, so when we add the next alternating term on there, we'll get this value as our sum. And then the next term goes in the other direction and is a little bit smaller. And I can keep bouncing back and forth like that. But whatever the case, we now know that no matter how many terms I add to this, the value of this function, of the sum of this series, is going to be somewhere in this interval. And so if I were to approximate the value by using just a sub 1 plus a sub 2 plus a sub 3, the error that I would get with this approximation that I'm highlighting here in fuchsia has to be no bigger than the error that I've highlighted here in green. Okay? The value of the sum of all the infinite terms of this series is going to be somewhere in that green highlighted interval. And so the error by approximating it at the fuchsia value has to be smaller than that. And that leads us to the alternating series estimation theorem. If we have an alternating series that satisfies the conditions of the alternating series test, the truncation error has to be less than u sub n plus 1. And it will have the same sign as the first unused term. So let's go ahead and we'll look at example 5 here. Estimate the value of the sum from 1 to infinity of the quantity negative 1 to the n over n squared using the first 15 terms. Wow, that's a lot of terms. Then use the alternating series estimation theorem to find the upper bound for the truncation error of this approximation. Alright, so I'm going to find the sum of the first 15 terms. Holy smokes. Alright, so we've got negative 1 to the first times 1 over 1 squared plus negative 1 to the second times 1 over 2 squared. My goodness, do I really want to write all that out? So anyway, we've got, let's just write these out. We've got negative 1 plus 1/4 minus 1/9 plus 1/16 minus 1/25. It's the first 5 terms, plus 1/36 minus 1/49 plus 1/64 minus 1/81 plus 1 over 100 minus 1 over 121 plus 1 over 144 Okay, and that's going to give us the sum of the first 15 terms. Wow. So I got -1 plus 1/4 minus 1/9 plus 1/16 minus 1/25 plus 1/36 minus 1 almost there. All right, and we get as the approximation for this -0.82454. -0.82454. Okay, and our error in this approximation has to be no bigger than the next term. And so the error has to be less than 1/256, because the next term is going to be 1/256, which is about 0.00391. And the error has the same sign, so we indeed know now that the value of this series for all the infinite number of terms has to float somewhere between -0.82454 and -0.82063. So we've narrowed down considerably the actual value of this. It has to be somewhere in the interval between -0.82454 and -0.82063. All right, let's look at our next example. This is from free response number 6 from the 2012 AP Calculus BC exam. This function g has derivatives of all orders, and the Maclaurin series for g is shown there. Sum from 0 to infinity of -1 to the n times x to the 2n plus 1 over 2n plus 3. And they give us the first couple of terms. The Maclaurin series is evaluated at x equals 1/2 as an alternating series whose terms decrease in absolute value to 0. Therefore, we know that it's convergent. The approximation for g of 1/2 using the first two non-zero terms is 17/120. Show that this approximation differs from g of 1/2 by less than 1/200. So we got this approximation here using the first two non-zero terms. So we use these two terms. That's some ugly highlighting there. We use those two terms to determine our approximation. Because of the alternating series error estimation, we now know that the error in this approximation has to be off by no more than the value of this third term. And so, to find the error of the approximation, we're just going to put 1/2 in here for x. And that's going to be 1/32/7. Which is 1/224, and 1/224 is less than 1/200. And so we've shown that the error of the approximation has to be less than 1/200. That wasn't too bad, especially for an AP free response question. All right, that's the end of this lesson and the end of this video. See you guys next time. Have a great rest of your day.